Hello all, I am Mahalakshmi, working as an assistant professor in physics in Hindustan College of Engineering and Technology, Coimbatore. Today we are going to discuss a few topics in fiber optics. Let us see what is an optical fiber, how light is propagated in optical fiber, what is principle and propagation of light in an optical fiber. Let see the topics. Introduction. Fiber optics is a branch of physics which deals with the transmission and reception of light waves using optical fiber. The principle behind the transmission of light waves in an optical fiber is called total internal reflection. A light beam acting as a carrier wave is capable of carrying information more than that of radio waves and microwaves because of its high frequency. Radio waves has a frequency of 10 power 6 Hz, microwaves has a frequency of 10 power 10 Hz, and light waves has a frequency of 10 power 15 Hz. Why fiber optics? Fiber is the least expensive, most reliable method for high speed and long distance communications. What is fiber optics? Transmitting communication signals over hair-thin strands of glass or plastic. It's not a new technology. It's a century-old technology commercially used since 1980. Structure of an optical fiber. An optical fiber is a very thin, flexible thread of transparent plastic or glass in which light is transmitted through multiple total internal reflection. The diagrams depict the parts in an optical fiber. It has a central core surrounded by a cladding and it is surrounded by a strengthening membrane and outer jacket. This is a fiber optic cable where it has a core and it is surrounded by plastic cladding, and these two are protected inside plastic coating, and there is a light ray which propagates through a core. Refraction of light. Speed of light changes as it crosses the boundary of the two media. And working principle of laser. The working principle of laser is by total internal reflection, TIR. When a ray of light travels from a denser to a rarer medium such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium, and this phenomenon is called total internal reflection. In the optical fiber, the rays undergo a repeated total number of reflections until it emerges out of the other end of the fiber, even if the fiber is bent. Snell's law. N1 by N2 equal to sine theta 2 by sine theta 1. N1 is the refractive index of one medium and N2 is the refractive index of a slow medium. The critical angle. Angle of incidence at which angle of refraction equal to 90°. The principle behind the transmission of light waves in an optical fiber is called total internal reflection. The phenomenon of total internal reflection takes place when it satisfies the following two conditions. Light should travel from denser medium to a rarer medium. That is, N1 should be greater than N2, where N1 is the refractive index of denser medium, that is the core. N2 is the refractive index of rarer medium, cladding. The angle of incidence should be greater than critical angle. Theta 1 must be greater than theta c, that is theta I is called angle of incidence and theta c is called critical angle. Let the light ray travel from denser medium to rarer medium. The reflection and refraction at the interface is a result of the difference in the speed of light in two materials having different refracting indices. Case 1. When theta I is less than theta c, the ray is refracted into the rarer medium as shown in figure. Then when theta I is equal to theta c, the ray travels along the interface so that the angle of refraction is 90°. This angle theta c is called critical angle. When theta I greater than theta c, the ray is totally reflected back into the denser medium itself, and the phenomenon is called total internal reflection. Condition for light ray to travel in an optical fiber. The angle of incidence theta I and the angle of refraction theta R are related to each other and to the refractive indices of the dielectrics by Snell's law of refraction, which is represented as n1 sin theta I equal to n2 sin theta R. Sin theta I by sin theta R equal to n2 by n1. When theta I equal to theta C by Snell's law, n1 sin theta C equal to n2 sin 90. Therefore, sin theta C by sin 90 equal to n2 by n1. Therefore, sin theta C equal to n2 by n1. Theta C equal to sin inverse of n2 by n1, where theta C is the critical angle, n1 and n2 are the refractive indices of the denser and rarer medium respectively. The figure shows the three conditions for light ray to propagate in an optical fiber. That is, first case, when theta I is less than theta C, theta I equal to 90 and theta I greater than theta C only, that light is totally internally reflected into the denser medium itself. Total internal reflection. A medium having lower refractive index is called rarer medium, while a medium having higher refractive index is called a denser medium. And the three diagrams as shown in the previous are shown also here. And when a ray of light passes from denser to rarer medium, it is bent from the away from the normal in the rarer medium. Snell's law is theta I is angle of incidence and the rarer medium, and theta 2 is angle of refraction in the other medium. And when theta 1 is greater than theta less than theta C, the ray refracts into the rarer medium. Theta I equal to theta C, the light just grazes the interface of the rarer to denser media. And if theta 1 equal greater than theta C, the ray is refracted back into the denser medium itself. This phenomenon, in which light is totally reflected from a denser medium to a rare medium boundary, is called total internal reflection. The rays that experience total internal reflection obey the laws of reflection. Therefore, critical angle can be determined from Snell's law. That is, theta 1 equal to theta C, theta 2 equal to 90. Therefore, with this equation we get n2, the rarer medium, with mu 2 is equal to 1. Writing mu 1 equal to mu, we get mu 1 sin theta C equal to mu 2 sin theta 90 degree, where theta equal to 90 equal to mu 2. Therefore, sin theta C is equal to mu 2 by mu 1. The rarer medium is air, mu t equal to 1. Writing mu 1 equal to mu, get sin theta C is equal to 1 by mu. So, principle of fiber optics. When light traveling in an optically denser medium hits a boundary at an angle larger than critical angle for the media, the light will be completely reflected. This is called total internal reflection. Fiber optic cables use total internal reflection inside the optical fiber. Light enters the optical fiber and every time it strikes the edge of the fiber, it experiences the total internal reflection. This way, light travels down the length of the optical fiber. Fibers can be bent. Types of optical fiber. Optical fibers are classified into three types based on materials, number of modes, and refractive index profile. Based on materials, they are classified into glass fiber, plastic fiber. Based on number of modes, it is classified into single mode fiber, multi-mode fiber. Based on refractive index profile, they are classified into step index fiber and graded index fiber. Classification based on material can be classified into glass and plastic fibers. Step index fibers, the refractive index of the core is constant along the radial direction and falls suddenly to a lower value at the core cladding boundary. Graded index fiber, refractive index of the core is not constant but varies smoothly over the diameter of the core. It has a maximum value at the center and decreases gradually towards the outer edge of the core. At the core cladding interface, the refractive index of the core matches with the refractive index of the cladding. The refractive index of the cladding is constant. Now the figure depicts step index fiber and graded index fiber. Graded index fiber, the refractive index varies gradually between the core and cladding, but in step index fiber, the refractive index difference between core and cladding varies step by step. And based on modes, fibers are classified into single mode and multi-mode fibers. Single mode fiber has a smaller core diameter and can support only one mode of propagation, whereas multi-mode fiber has a larger core diameter and supports a number of modes. There is more than one mode, which is also called multi-mode graded index fiber. Classification based on materials, and the optical fibers under this consideration are glass fibers, glass core with glass cladding, plastic fibers or plastic core with plastic cladding, PCS fibers, polymer clad silica. Thank you all.